Hey guys, so in this video we're going to be looking at the logarithm laws. So this is looking at how you can change around log functions, so you can simplify them and also write them differently and express them differently. However, it also relates to the index laws a lot. So if you don't know the index laws, make sure you go back, look at that video and become familiar with them, as the logarithm and index or power functions are very interrelated. So that's like the a to the x, so example like 2 to the 3, etc. And so you can go from that sort of form to the log form and then back again, and that's useful for simplifying as well for many other applications. So to begin with, the logarithm law. So what is the log function? So this is talking about the log function. So this is when you have questions such as, when you have an expression such as log to the 2, or log to the 3, 9. So it's in that form. We have log a to the b. And you can change a to the b. A is sometimes normally set at either 10 or at e. So that's like a 2-point sort of number, which is approximate, so that's useful. However, normally it is stated. So log 3 to the 9. But what does this actually mean? So log 3 to the 9, or what the log function means, is it's basically saying if it's 3 to the x is equal to 9. So it's saying for the base, what exponential, like what index or what power is needed to get the result of 9, or what is in this brackets. So in this case, we know it's 2. So the answer to log 3, 9, the value is equal to 2. And we can see that if you have log 10 to the 10, then it's going to be 10 to the 1 is equal to 10. So that is equal to 1. And you have log 10 to the 100, the answer is going to be 2. Log 10 to the 1000, the answer is going to be 3. Now you can see how the log and the power or the index functions are interrelated. So you can say it's 1, 2, 3. And then this is useful understanding this when you're graphing it, as I've been increasing from 10 to 100, so large increases, and then 100 to 1000, which is really large. But the result is not being that large. So that's a huge increase. But then you're only going from 1 to 2 to 3, which are small increases. And that's because you're putting whatever the base is to the power of these numbers. So you're going to get a much larger number by smaller changes to the power. So you have 3 to the x is equal to 9. So that's how the log function works. And then it's important to understand for the later rules. And if you understand how it relates to the index laws, then you'll be able to work out and see how lots of the log functions are defined. Firstly, what does log a to the a equal? Well, if you remember back what the log means, that's effectively saying a to the what is equal to a. Well, it's always going to equal 1, no matter what a equals, because 3 to the 1 is equal to 3, negative 5 to the 1 is equal to negative 5, 100 is to the 1 is equal to 100. So we can show that log a to the a is equal to 1. What about this one? Log a to the b squared. Now, at the moment, I'm just putting squared in there too, but this could be a general function. Now, this is equal to 2 log a b. So in general, you can write this as log a to the bc is equal to c times log a to the b. So effectively what we've done is we've turned that index and we've brought it down and it's multiplying. And the reason for this is that, let's say we're going back to the function we had before, so log 3 to the 9 is equal to 2. And we showed this. What about now if I said log 3 to the 9 squared? Well, what's that answer? Well, that means we have to find 3 to the x is equal to 9 squared. So 3 to the x is equal to 3 squared, or 3 to whatever number, let's say a, squared. So the a is referring to this, so log 3, 9. So if we just had 3 to the a is equal to 9, therefore that's what the value a is there, because we've just subbed in 9 for 3 to the a. Now because if you remember the index laws, 3a to the power of 2 is equal to 3 to the 2a. So you've times it together. So now x is going to equal 2a. So a before was equal to log 3, 9. So now if we want to know log 3, 9 squared, it's just equal, so log 3, 9 squared is equal to 2 times log 3, 9. Then you can make 2 into a general sense where it's just c, and you can see how all the different powers, no matter what value they are, you can apply this as well. So that confused you a bit. Don't worry too much. Look at it, try and understand it, but the main thing is to remember this law here and be able to apply it. So what's log a to the 1? So log a to the 1 is effectively a to the x is equal to 1. So we want to find what x is. So this is equal to x. Well, if we have 2 to the x is equal to 1, then x will equal 0. Because 2 to the 0 is equal to 1. If you remember the log law, the index law, that a to the 0 is equal to 1. Now it doesn't matter what value we put, it's always going to equal 1 if we put it to the power of 0. So 3 to the 0 will equal 1, 100 to the 0 will equal 1, negative 5 to the 0 will equal 1. And we can see that log a to the 1 will always equal 0. So what happens when you have log a to the x when x is less than or equal to 0? Well, this is actually undefined. That's because what we're doing is we want a to some value, so we'll let this equal b. So we need to find a power. We have a to the power of a number is equal to x, where x is a negative number. So let's put in some values. Let's say 3 to the what is equal to negative 4. However, we know that with index, is b is positive, then 3 on b will be positive. And then if b is negative, then we have 3 on negative a number, so let's say negative 4, and that's equal to 1 on 3 on 4. So it's going to approach 0, but it's still going to be greater than 0. So no matter what, this number here is always going to be greater than 0. So that means it can't equal negative 4, so it's undefined. And also if x is equal to 0, then we have a to the b is equal to 0. Even when b is a really negative number, it's still going to be greater than 0 even though it approaches. It's going to be a very, very small number, but it won't be equal to. When b is equal to 0, then we have a to the 0, which is equal to 1. And 1 is obviously not equal to 0. So when you have log a to the x, and x is a negative number, then it's undefined. Important note for when graphing, let's say you have log to the 3 is equal to x minus 4, then x doesn't have to be less than or equal to 0, but it's what is in the entire function here. So it's at x minus 4. So with that graph, we'd have to say that x minus 4 has to be less than 0. Therefore, it can't be less than 0. Therefore, x minus 4 has to be greater than 0. That means x must be greater than 4. So just be careful that when we're referring to x, we're not actually referring to the value x such as in the graph when you're graphing. However, we're referring to that entire term there, such as x minus 4. Referring back to the index laws, we saw that a to the x times a to the y is equal to a to the x plus y. So we saw that the multiply changes to plus. Now with a log, it's the opposite. So when you have two numbers being added together, such as log am plus log an, then when you combine them, we get them multiplying together. So here you have the positive, and then it changes to multiplying. Then the other way around, you can also have negative, and it changes to dividing. And you can go either way for these equations. So such as if you had log to the 3, 9 on 4, this is equal to log to the 3, on 9 minus log to the 3 on 4. Now it's really important that you know these two equations to be able to use them. So have a look, make sure you know them, and just be careful is if you have a question such as log to the 2 is equal to 3 plus 4, then this is not equal to log to the 2, 3 times log to the 2, 4. And you can see the difference here is multiplying, here is dividing. But if you have log to the something, then they're adding inside. You can't simplify it using the log laws we have learned. So you have to add them together and then simplify from there. However, with here, if they're multiplying, then you can split them up. Or if there's log a something is inside plus log a something inside as well, then you can times them together.